All right, Math 8 students, we are doing lesson 7.3 today. This is equations with the distributive property. It is essentially just identifying what we've already been doing in solving equations with variables. So you can use the distributive property to solve equations, but what is the distributive property? What is it? What does it mean? Well, we identified it in 7.2 notes as the rule that if you have A times the quantity of B plus C, that you can distribute this A to each term inside the parentheses, and it is the same as saying A times B plus A times C. So that is what the distributive property lets you do, is it lets you distribute this term inside the parentheses, and it lets you solve. And it is multiplication. When you're distributing, you're multiplying. So we've got example 1, and this is a lot of this is going to look like review, but we're giving a name to what we've been doing in lesson 7.1 and 7.2. So example 1 gives us the equation 3 times the quantity x minus 5 plus 1 is equal to 2 plus x. So we've got the steps listed over here. Just in case we forgot them, we've got this quick reference. And the first thing that we're going to do is use the distributive property. And we're going to distribute 3 to the terms within the parentheses. So 3 is going to get multiplied by x and multiplied by 5. So our equation will now be 3 times x minus, I keep that minus sign, 3 times 5 plus 1 equals 2 plus x. Because I'm only distributing there with the terms in the parentheses. So then I'm going to simplify, as it tells me to do. So I've got 3x, that's already simplified, minus 3 times 5, which is 15, plus 1 equals 2 plus x. And I can continue to simplify this. If you'll notice, I've got a constant term here and a constant term here. So I've got essentially negative 15 plus 1. So if I combine these, I end up with 3x minus 14, right? 15 negatives, 1 positive gives me 14 negatives, equals 2 plus x. Okay, so now I've got that simplified. I distributed, I simplified. So now I'm going to look at my next step, which is to use inverse operations to solve the equation. So I'm going to subtract x from both sides. So my x term here, this is the same as 1x minus 1x. That cancels it out on one side. And then I combine these terms here. Remember, this is not 3 minus 3 plus x. This is 3 times x. So remember, every time that you have x by itself, it's the same as 1x. Some of you guys have been putting that in there as something helpful to make sure that you're not just subtracting the x term. So you've got 3x minus 1x, which is 2x. Bring down what you haven't changed, so minus 14 equals 2. You're going to add 14 to both sides. That cancels it out on this side of the equation. What I've got left is 2x equals 16. Now I'm going to divide by 2. Because that's separating this, right? I can separate this because this is multiplication. I can separate it using the inverse operation, which is division. 2x divided by 2 is 1x, and 16 divided by 2 is 8. So I've got x equals 8. And that's my solution. Now I could always check this by plugging x back into my equation, and if it is equal, if the solution on one side is equal to the solution on the other side, then it is true. All right, so we're going to go ahead and move on to example 2. And we've got a fraction here, and we want to eliminate the fraction. Now, this is telling you to eliminate the fraction first by multiplying both sides by 4. You could distribute first and then eliminate the fraction, but we're going to go ahead and eliminate the fraction first, and we do that by finding the LCD. So you need to find the LCD, which in this case is given to you. It's 4, so we multiply both sides by 4. And we have to multiply both sides because that's what keeps both sides equivalent. So I've got 4 times 3/4, which is going to then be multiplied by x minus 13 equals 4 times negative 2 And then that product would be multiplied by 9 plus x. Okay? So when I'm multiplying a whole number by a fraction, I turn that whole number into a fraction by putting it over 1. So that lets me cross-cancel. Nothing in common here. I get to cross-cancel here because these two have a common factor of 4. 4 divided by 4 is 1. 4 divided by 4 is 1. So now I have 1 over 1, which is the same as 1, times 3 over 1, which is the same as 3. So I have 1 times 3 equals 3. Right? So now I've got 3 times x minus 13 equals 4 times negative 2 is negative 8 times 9 plus x. Okay? So now I'm going to use the distributive property. Now that I eliminated the fraction, I'm going to use the distributive property. You could have switched these and distributed and then eliminated. That would be fine. Do whatever method works best for you. So I'm going to distribute the 3 inside the parentheses here and distribute that negative 8 inside the parentheses here. So I've got 3 times x, which is 3x, minus 3 times 13, which is 39, equals negative 8 times 9, which is going to be negative 72. Common error that we make, guys, is we lose our negative signs and we forget our rules for multiplying and dividing negatives. So make sure that you are keeping track of those. So negative 8 times 9 is negative 72 plus negative 8 times x, so that's going to be a negative 8x. Now you could leave this as a positive, or if you wanted to, you could rewrite this as negative 72 minus 8x. That would be fine. It works both ways. I'll just go ahead and rewrite that out. Oops, not 9, 39. Okay, and so then what I'm going to do is I'm going to use my inverse operations to solve the equation. And so I'm going to start out by adding 8x to both sides. So plus 8x, and I'm adding because it is a negative. I need to cancel it out. So plus 8x. So it is gone on this side, and then I have 3x plus 8x, which is 11x, minus 39 equals negative 72. Okay. The next thing I'm going to do is add 39 to both sides because I'm combining my constants. And remember, you can't bring 72 over because then you have nothing on this side of the equal sign, and you have to have variables on one side, constants on the other. And since this is a subtracting or a negative, I need to add 39. And then again, a lot of us get caught up here with our negatives and our positives. Remember that this is the same as just combining. You are combining negative 72 with positive 39. And so negative 72 plus 39 is going to be negative 33. So I bring my 11x down because that didn't change. So 11x equals negative 33. I've got 11 times something equals negative 33. So I need to divide because that's my inverse. Divide by 11. Divide by 11. This cancels out. I've got x equals negative 33 divided by 11, which is negative 3. So my solution is x equals negative 3. Okay, so that's the quick review of how to do that. We're going to do one more example, and that's how to pull these type of equations with using the distributive property from real-world solutions. So what I'd like you to do is flip that page over. We're going to look at example 3. And that's solving the real-world problems using the distributive property. So we've got this scenario where the Coleman family has their bills at a restaurant reduced by $7.50 because of a special discount. They left the tip of $8.90, which was 20% of the reduced amount. 20% of the reduced amount. So not of the original amount, of the reduced amount. How much was their bill before the discount? So we need to first analyze the situation. We're looking for, well, what is our solution? What is it that we are given? What do we know? And so the solution is going to be the amount before the discount. So that's what we're trying to solve for. We're trying to find out what is X, right? The amount before the discount. Oh, I spelled amount wrong. There should only be one M. Amount before the discount. And then we're going to formulate a plan. So we're going to use an equation to find the amount before the discount, right? So what we need to do is we need to create an equation. So we've got 20% of the reduced amount. So we don't know the original amount, so we're going to make the equation of 20%. 20% as a decimal is 0.2. Okay, so that's what we need. So we need to multiply our original amount, whatever that is, by 20%. So that's the amount that we're going to have to distribute to our parentheses. So the original amount would be X, we don't know it, minus the reduced amount, which would be $7.50. And then we're going to add, so then we're going to set that equal to our tip, right? Because 20% of our total amount, our original amount, was the tip, the amount that they left for tip, which was $8.90. Okay? So 20% of the original amount was $8.90. So that's why we set this equal. So now what we're going to do is we are going to use the distributive property. So we're going to distribute that decimal within the parentheses, that 20%, or that 2/10. So 0.2 times x, or 2/10 times x, is going to be 0.2x minus 0.2 times 750, and that's going to be 1.5, or 150. And then we're going to set that equal to $8.90. Do you have to have this 0? No, you don't. You could just have 8.9 and that would be fine. In fact, I'm going to go ahead and get rid of that because we don't need it. Okay, so now I've got an equation that I need to solve. And what I'm going to do is I'm going to use the distributive property and inverse operations. You can solve here with these decimals if you'd like, or you can use the method that we've been using before to eliminate the decimal. So I'm gonna do two methods here. I'm gonna do this method, this first method, where I don't eliminate the decimal and I just solve. And then I'm gonna do another method over here where I eliminate the decimal and solve. And you'll see that both methods will get me the same answer, assuming I don't make any errors along the way, which, you know, I do. I'm human too. So let's go ahead and take a look. And what we're going to do is we are going to combine like terms, right, using inverse operations. So I'm going to add my 1.5 to both sides. And I do that because I can't, my variables are already combined. There's nothing to combine this with. And I can't move my 8.9 because then I have nothing on that side of the equal sign. So now I've got 0.2x equals 10.4. Okay? So then I'm going to divide by 0.2 on both sides. And I have x equals 10.4 divided by 0.2. Remember, when you are dividing decimals, if you're doing this longhand, top in, bottom out, 10.4 divided by 0.2. When you divide by decimals, this is a little tangent here, you need to move the decimal in that front number until you have a whole number, and move the decimal on the inside to match the number of times you moved it on the outside. So you would now have 2 and 104, and then you would solve as normal. So when I solve that, I get the answer 52. So x being the original amount, that means that the original cost of the bill, the original amount of the bill, was $52. So was my original amount. So $52 was my original amount. Okay, so I'm going to take a little tangent here, and I'm almost done. And I'm going to just show you how you could have solved by eliminating the decimals. If you are fine using this method, that's fine. Go ahead and just fast forward to this next part. If you want to see more examples of how you eliminate the decimals, watch this portion here. I'm going to take a look at how many spaces I have behind the decimal. In this case, my place value, number of place values that I have, let's try this again. The number of digits I have behind the decimal is 1 for each one. I don't have any more than that, which represents my tenths place. So I'm going to multiply every one of these terms by 10. So 10 times 0.2x minus 10 times 1.5 equals 10 times 8.9, and I'm going off the page here. Hopefully you guys can still see that. When I multiply by 10, I'm moving the decimal once. And so this means that I now have 2x minus 15 equals 89. And now I can solve as usual. So you can see now that I'm not working with any decimals. I'm going to add 15, which is the same as what I did over here where I added 1.5. I've got 2x equals 104. I divide by 2. And I have x equals 52. So I get the same solution no matter which method I use. This one does have an extra step, but it does allow you to get rid of the decimals. Okay, and so then the last thing that you would do is justify and evaluate. So you would check your solution. So you would plug that number back into the equation to check and make sure you got it correct. So you go 0.2. Let's get a different color here. 0.2 times 52, because we determined that that was our value of x, minus 750 equals 8.9, or $8.90. So if I work that out, I should end up with the solution that is accurate, right? So this would be 0.2 times 4450 equals 890. And when you work that out, you do in fact see that 0.2 times 4450 does in fact equal 8.9 or 8.90. So our solution is correct. All right, so what I've got now, guys, this is all of the required notes that you have, but I am going to do 3 additional examples. If you would like to see a few more examples of the distributive property and solving with variables on both sides, just a few more examples of what we've been doing in 7.1, 7.2, and 7.3. So these additional examples are optional, but if you are still confused, you should watch this or at least use them as practice and then fast forward through the video to check your answers and make sure you got it right. As always, if you have questions, you should be writing those down as we go through and bringing them into class so we can go over them together. Okay, so these additional examples will be in a second video that I will post with this video. Again, these additional examples are optional, but they are there for you if you need them. I will see you in class.